Hello, welcome to this demonstration of the Building and Asset Tuner solution by Negawatt Energy Solutions. The Building and Asset Tuner is designed to interact with any building which has an existing building management system or building automation system in place. So long as that BMS has the ability to accept protocols in BACnet, Modbus or the Tritium Niagara protocol. This covers probably about 95% of the market. Some BMS solutions may require the BACnet bridge be installed if there's not the capability at the moment to take BACnet, Modbus or the Tritium protocol. This is something that we just need to sort out on a case-by-case basis if the BACnet IP solution isn't currently available. So moving into the solution, it's a fairly intuitive solution. It is a web-based, cloud-based option, so it does, as I say, interact with the existing BMS, and it does so remotely through a secure internet connection. There's a lot of applications which sit within the solution, but the main one which most people will use sits within the reporting application, where we've tailored a number of reports and where the main home pages are. It's broken into 5 key areas: the curtailment section, energy conservation measure recommendations, energy reports, equipment reports, and the set point resets. The 3 key areas are within curtailment, ECM recommendations, and set point resets. So we'll start with the curtailment. So we go to the home page. And in the curtailment homepage, this is where we are putting in place strategies to make sure that you are able to set a maximum demand threshold and not exceed that threshold. So in this example, the customer was being penalised for a one-off spike in demand that occurred 10 months ago and been paying capacity charges for that one-off spike ever since. In working with the customer, we identified the target that they wanted to cap at was 350 kVA. So we've put that as our top end threshold that we want to achieve. We've also put in 2 secondary thresholds, 300 kVA and 340 kVA. So as we're approaching those thresholds, potentially getting to that 350 kVA mark, we can start to put in place remedial action to ensure that we don't hit that 350. If we do, then there's a 350 kVA strategy, which is effectively scaling the HVAC back very aggressively for a brief period of time to make sure that demand threshold isn't exceeded. So the 3 thresholds that we've put in place and what occurs. At curtailment level 1, it gets triggered anytime the kVA's 20-minute average exceeds 300 kVA. Now the reason we use a 20-minute average is because the networks use the 30-minute interval data. So if we're reading it at a 20-minute average, it gives us 10 minutes to mitigate against that increase, make sure that the 30-minute average is below the target that we've set. So at level 1, the following settings are made. We're changing the heating set point offset to the present value plus 1 degree and the cooling set point offset to the current value plus 1 degree. So we're effectively putting the set point up by 1 degree. Now the reason that we changed the offsets where they're available rather than changing the set point is that a number of tenants have in-tenancy displays where they're able to make some level of control, but it displays the current set point target. If we were manipulating the set point target, floating it up, they may be looking at that display thinking, I want it to be 22 degrees. The target says it's going to be 23. I want to try and change that. Oh, I can't change it. So they'll make complaints. So by changing the offset, the set point stays the same. They're looking at a display that says 22 degrees, but in reality, with this offset, we're actually moving towards a set point target of 23. So it keeps the occupants happy because they're seeing that visual. As long as they're not feeling uncomfortable, there's no reason for them to make complaints to the building manager. In curtailment strategy 2, we start to get a little bit more aggressive. So as we hit the 340 kVA mark, the FCUs are increased by an additional half a degree. So we're now 1.5 degrees above the previous set point setting. Same with the VAVs, but we're also changing the AHU static pressure set point to 80% of the present value. So we're starting to get a little bit more aggressive with the changes that we're making. If those changes don't get down to a level that is within those thresholds, curtailment strategy 3 is triggered when we hit 350 kVA. So this is where we're starting to get more aggressive. The FCUs are all pushed up by an additional half a degree, so we're now 2 degrees above the existing set point. The chilled water loop, the discharge pressure set point, is reset to 80% of the present value. We've still got the AHU pressure set point set to 80% of present value in curtailment 2. Plus we're then also changing the chiller demand limits back to 40%. So we're effectively scaling the whole HVAC system back to a minimal performance just for a brief period of time to improve the performance and reduce the demand. We also provide the ability for building managers to be able to manually start the curtailment strategies. So it may well be that the network is notified that it's a peak demand event day, so demand will be charged at a higher rate, in which case the 300 kVA may not be an acceptable target. So the building manager can manually intervene, use curtailment strategy 4 to kick off all the curtailment plans if they believe that demand is reaching a level that they think is unacceptable. In the display, we're showing the recent history on what's been happening. So we're showing the total site KVA, which is the light blue line. So you can see the demand profile there. We're showing the thresholds, the targets. So we're looking at the curtailment level 1, 300 kVA, 340 kVA is the green line, and then we're looking at the curtailment 3, the 350 kVA purple line. We're also putting in place overlaying the outside air temperature, so you can see what the external air temperature is relative to the demand that we're currently tracking along with. Within the curtailment homepage, we have the ability to look at what the current set points are. So we can see at the moment curtailment level 0, current kVA demand is 179 kVA, so it's looking good. Demand is well below the thresholds. There's no curtailment strategy in place. We can have a look at the set points. So if we're looking at there's a curtailment strategy in place, we want to see what's happening. We can actually see at the moment there's no intervention, but if curtailment strategy 1 was in place, we would see that additional 1 degree going on here. So the standard right is 0.5 degree for the offset. This would change to 1.5 degrees. We also have the ability to exclude specific zones from the curtailment strategy. So if on implementation there's a particular zone that is complaining that the temperatures aren't within an acceptable threshold, you can exclude them from the plan so the curtailment strategy won't apply to them. So you can see in this example there is nothing being applied, it's been excluded from the reset. So it just tracks along based on the standard settings that are put in place with the BMS. You also have the ability for the building manager to change the settings. So we use the adjust curtailment settings, and this is where we can see what the current level is. So there's currently no threshold in place, but importantly we can change the threshold. Make that value to whatever you want it to be, and that will take place immediately, and that threshold curtailment plan will kick into place when that new threshold is hit. We've also provided the break glass button. So if there's a curtailment plan in place, it's running at the moment, you can see that it's active and you're getting a lot of complaints, then you can come in here, turn curtailment off, and it will immediately revert to the standard settings within the BMS. And then we can have a look at what's gone on and see if we need to fine-tune the curtailment strategies. Now here's an example of a curtailment that has kicked into play. So we've seen the demand tracking along. It's briefly hit up to the 412 kVA mark. So kVA level strategy 1 has kicked into play. We've exceeded that mark for longer than we consider appropriate. Level 1's kicked in. It's had a small impact on the demand, but not enough. So curtailment level 2 has come into play. So we see we've spiked up here, curtailment level 2, and immediately we've seen a very aggressive drop in the demand. And then the curtailment plans have reviewed, seen we're happy with the level of demand, turned the curtailment plans off, and the HVAC has just come into full normal performance, stabilised back to their normal load profile. So we've been able to prevent this spike, so it hasn't come through in the billing at 413 kVA. We got to it quickly enough to bring it down that the average kVA is below the chargeable threshold targets that we wanted to set. And you can see there, the whole thing started at 12 o'clock and then ended at 12:20. So for roughly 20 minutes there was changes within the HVAC. No occupants within the building made any complaints during this time, so it was a very effective curtailment with no impact to the occupants. So the other area after curtailment, so we're curtailing the demand, is the set point resets. So set point resets is where we're floating the current set points, and again, as I say, using the offset settings rather than the set point settings, to change what the current set point is relative to the external air temperature at the time. So at the moment, the curtailment strategy for this particular implementation is that when the outdoor temperature is below 15 degrees, the zone set point shall be 18 degrees. As the outdoor temperature rises to 25, the zone set point will rise up to 22. So between 15 and 25 outside, the set points will float between 18 and 22 degrees. When the outdoor temperature is between 25 and 30 degrees, the zone set points get set hard at 22 degrees. When the outside temperature floats from 30 to 35, the zone set point gets capped at 23 degrees. And then when the outdoor temperature exceeds 35 degrees, we're floating the set points up to 24 degrees. So you can see in the chart below where the example of the red line is the zone set point and the blue line is the outside air temperature. So you can see as the outside air temperature has increased, the zone set point has increased along with that. So it's within that thresholds that we've set. So it's currently 25.5 degrees outside. We've got an effective zone set point of 22 degrees. Again, you have the ability to enable, disable and adjust the resets. So you can go into them, turn it all off. So if floating the set points, you're getting a lot of complaints, you can turn it off, let the building go back to having the BMS control it and see if that fixes the problem and see if we need to adjust the floating algorithms that are being used, whether the targets are too aggressive. Similarly, you can go and change the levels that you want it to be. So at 15 degrees, what temperature do you want it to be? You can make that change, it applies immediately. You also have the ability, again, to include and exclude specific equipment from the reset. So you can go through, find the particular zone that you want to exclude, take it out of the set point reset algorithms. And you can see currently real time 26.5 degrees outside, set point is effectively 22 degrees. And again, review all of the current offsets for each of the zones. So it's currently set at 0.5 degree offset. We're rewriting it at 0.5 degree offset to float the temperature. Now the third key area within the system is where we're starting to do asset optimization. So it's not about floating the temperatures. This is about improving the performance of the infrastructure that you have in place. Now these normally aren't issues that would come up as an error within the BMS, so there's no red alerts being flagged. These are areas where you can improve the performance of the infrastructure by making changes or improving the way that they're operating to reduce the energy consumption. With these key opportunities that we've identified, this customer implements all of these. The estimated savings in energy consumption is between 20 to 25%. So there's some significant opportunities here. And it starts to flag things. For example, this opportunity here, the outside air temperature sensors failure. So we provide an overview of what the fault is. We've observed that the outside air temperature sensor is not changing value throughout the day. The recommendation: the outside air temperature controls the opportunities for free cooling, so putting the system into economizer mode. So if it's warmer inside than it is outside and we're trying to cool the building, we can vent external air into the building rather than run the chillers. At the moment, this particular site is not taking advantage of those opportunities, so it's always running the chillers to try and cool the building regardless of what the temperature is outside. We can see here the controls contractor has had a look at it. The sensor they thought looked okay, but it's actually not the chilled water sensor which they've looked at. It's the AHU points are reading 24.4 degrees consistently. We know the temperature doesn't stay 24.4 degrees 24 hours a day, so there's something that needs to be looked at there to try and fix that. Again, another opportunity. Chiller 2 is operating outside of the occupancy schedule. So the occupancy schedule has said that the particular times of the building that should be operating, but Chiller 2 is running outside of that time. So the opportunity, set the schedule for the chillers so that they don't operate outside of the building occupancy schedule, or even turn the chillers off slightly earlier than the occupancy schedule. If you want to have a look at the details, we provide a link there. And you can see the specifics that we're talking about. So you can see the chiller discharge. We're looking at the capacity and the demand limits within the chiller. We're looking at all of the discharge pressures, but most importantly, Chiller 2 enable is running at 20 past 6. And we know that the operating range is till 6 o'clock. So if it's still running at 20 past 6, there's something that needs to be reviewed. So in all of the energy conservation measure opportunities, there's a report provided. Our engineers reviewing the system constantly. Every month they have a phone hookup and a web conference where we go through the application with the building manager, review all of the energy conservation measure opportunities, look at what has been actioned, whether there's some we can close off, if there's any that are still under investigation, and more importantly, or as importantly, if there's any new opportunities that have come up, discussing the detail of those opportunities so that the building manager can go and pursue those. And as I said, that happens on a monthly basis where it's all reviewed. We're reviewing all of the settings, making sure that we're achieving the maximum outcomes that we possibly can. Now the other interesting thing is a lot of BMS systems provide a real-time view of what's happening, but don't provide the ability to look at historical data. So using the example of a zone that's complaining about the temperatures, we're able to go and look at a specific zone within the building. So we'll go and open up the specific zone. and they may be saying, you know, we're not getting it warm enough within our offices. You know, we're setting the set point up, but it's not getting any warmer in our office. So if we're looking at the zone, we can see, well, yeah, it was a pretty cool day. We can see the green line, they've pushed the set point up, but because the curtailment plan's in place, we've also floated the offset. So they're pushing the set point up, we've pushed the offset up to achieve the target that we're aiming for, which is what we wanted to achieve, which explains probably why it's not getting a whole lot warmer. But given the set point that had been established, it should be getting warmer in that office. And then we look down here and we see the fan status. The fan hasn't actually been turned on. So that explains making a change to the set point on the in-office control, but not turning the fan on isn't going to make that office any warmer. So they need to be turning the fans on. So the building manager can look at this and very quickly identify, tenant, you need to be turning the fans on, show them how to use the controls properly. And we can see here, when they started turning the fans on, the temperatures started to change. So they're turning the fans on, it's getting warmer, they turn the fans off, it's cooled back off again until they turn the fans on and it's coming back up, warming their environment. So we're starting to see it effectively controlling their environment, where they're not turning the fan on, the office isn't going to magically heat up itself. So you have the ability to start to look at specific pieces of equipment. Now, just an example of what happened on implementation for this particular site. On the left-hand side here, we have the energy profile for the day before the system was implemented. And then on the right-hand side, we've got the system demand, the energy profile for the day after it was implemented. So we implemented overnight, and you can see the very dramatic change in the energy profile that occurred. So that just demonstrates that there has been a very appreciable change in the energy profile with the implementation of the building tuner. So it's working effectively, it's achieving the outcomes. From implementation, there were 2 occupants which complained, but they were also occupants that had been complaining about conditions prior to the implementation. So just to make things easier, those 2 zones have been excluded from the curtailment plans, and we're not intervening in those. But every other zone within the building is being managed, floating the set points, curtailing the demand without any adverse feedback from the occupants. So that's the building and asset tuner solution. If you have any questions, feel free to review our website for frequently asked questions. Alternatively, you can speak to your distributor or agent and contact us for further information and an interactive demonstration.